Today we're going to be looking at facility management technology, FM technology. Everything we're going to be looking at today is how to bring some automation, how to bring some flexibility and scale to our operations, and how to strategically think about getting things done better. If you take this as an extension of the quality class, you see it as a way to automate some of those quality measures we have discussed in terms of data gathering and using those data to optimize processes. Because if you have processes in place, human beings will have to implement those processes at every step. But if you have technology in addition to processes, then of course you have a complete end-to-end solution that makes sure, provides efficiency and effectiveness for your operations. So basically, when we manage facilities, we manage a whole lot of things. We manage spaces, allocate spaces, we furnish spaces, we fix, we maintain, we do projects, all kinds of projects. We have asset data, maintenance programs, quality assurance documentation. We have, financial documents about costs and everything that we do, including how we integrate the people that use the spaces, as well as the places and the processes. All of that is now bound together using technology for integration. In essence, the data from one process or from one system in your facility feeds into another. It's a system way of thinking. If you have inputs, you have process, you have output, right? The outputs from one process or from one set of activities become the inputs to the next. So the data that comes out of my asset acquisition, how much I paid for the assets, installation costs, and all of that, they go into my financial system. And then when I go on to do maintenance and operations, of course, I've done some condition assessment, I have my replacement value, I have costs that are going to go into each of those activities. All of them integrate into my operations and maintenance again. So in essence, I need to continually accumulate data and use this data for intelligence. That's basically what we do when we are managing facilities. So when we talk about FM technology, it starts with the basics. Where are the data coming from? How do we use the data? And how does those data transform into efficiencies and effectiveness? Okay, so I can break this down for you. Take you back to when facility management was just basically a series of work orders on paper, logbooks where we record inventories and people sign for stuff. And then we have some spreadsheets when we started, upping our game in terms of technology. We started having some spreadsheets where data from work orders, from inventory logs, from bin cards, from security logs, from maintenance logs, and so on, and now entered into spreadsheets so that we can do a little bit of analysis. So we can create some kind of trend, we can see patterns of how those numbers are working, including when we do customer surveys and so on and so forth. Now, we have moved from just spreadsheets, of course, paper to spreadsheets, and spreadsheets to software. Okay, what we have now done with software is we have now automated the process of accumulating those data from the various sources into the spreadsheet, no longer into spreadsheets manually. Those data can now be automated into a software. The analysis we normally will go back to do are now pre-programmed into a facility management software, whether you're using it for inventory, for asset management, for space planning and analysis, for financial, for bidding, and all of that goes in FM. It's now automated. So the data is acquired, the data is analyzed, and then the software goes a little bit beyond, because now the software can now take certain decisions certain logic are now written into software to make them able to act on our behalf. Okay, so reminders, prompts, and actually being able to make certain changes to certain other types of building technologies in the building. So the ones that I've described so far when I talked about paper to spreadsheets to software to integrated work management systems that can actually integrate with the building, I'm talking about technologies for managing facilities. Those are the kind of technologies that I need as a facility manager to manage facility, which is basically data processing, analysis, and action from those data. Now, the building themselves that we manage has also evolved with the increase or deployment of technology. So we now have, okay, we used to have basic buildings. You wake up in the morning, you open your windows by yourself, you put on a switch in fact, switches on their own are technologies, right? So on the side of the building, there were times before in very distant past where you needed to actually put a bulb into a lamp holder to have light. When you don't want it anymore, you took it off that lamp holder. Switches evolved into, and then you now have valves, you have actuators, you have automatic switches that can change over, for example, the ones that can come on at so time and count down to another time and go off. And then you start having sensors that can actually respond to things like light, photosensors that can say, oh, it's morning time, the sun is coming out, let's put off all lights. And that sends a signal to a real switch that does the switching, tells the switch it off, right? And then that now replaces you as the individual coming to, put off that switch. We have moved from all of those just switches and controllers and valves and gauges to more sophistication now. Buildings have now evolved in terms of technological sophistication. We now have sensors that can be built into your building components and your equipment that take information, feed it into the integrated workplace management system or software that help you manage. So instead of me to go, for example, to read a meter and put information inside my software and gather that information on a regular basis, I can now integrate my management system with my building so that the meter can now have an IP connection so you can put its information in the cloud, and my software is also getting that information in the cloud and can tap that information and create my analysis. Beyond that, we now have building management systems and building automation systems. Building management systems get information through sensors, feed it into a central position, and gives you visibility to those data so you can take action. I can see that the CO2 level in the certain space is too high. I need to bring in more fresh air into that environment, and then I activate the dampers that will open up and allow more air in through the air handling units, right? I can do that, but that's a building management system. That's what it does. It shows me what's happening through sensors connected to generators, to light systems, to elevators, it brings all of that information to me, and I can take action. I can decide to reduce the cooling by pushing some controls, increase the cooling in certain spaces by pushing some controls, reduce light, increase light, reduce hot water, and so on and so forth, right? Now, but a building automation system takes that a little bit further by having a predetermined, pre-clocked in logic of what I will do if the numbers are like this. If CO2 level is like this, what will Mr. Paul do if he's the manager using the BMS? Mr. Paul will open and allow fresh air until oxygen is back up to maybe 20% or 30% or whatever percentage I set as my targets. Those are the things I would have done, but I don't want to do them because, and that's why I'm moving from the BMS to a BAS. what I now do is I pre-configure that my logic into the system, and the BAS will get this from the sensor that the oxygen level is too low, and automatically send that information to certain actuators and damper control valves to tell them to open up and allow fresh air in, right? And when the fresh air is a certain level, the information is sent back through sensors, and then information is taken by the BAS system to those controllers to shut off those valves and stop the fresh air from coming in, and so on and so forth. So all of this information you cannot really install any of this technology, whether from technology for managing your software or managing your system, spreadsheet software. We'll talk about all of them as we go on, or technology for managing the building that are built into the building if you don't have basic information. So data about the assets, data about the building, data about the configuration of the building systems, data about the processes that you use to operate your building are all required. They all need to be integrated into your FM IT software. So whatever system you want to run with, you need to first think about what data, what processes, okay? Okay, so technology covers everything from the build into the building and the management system. Let me take you into these two categorization a little bit further. You have on the building management systems where we evolved from as managers of FM. From a paper-based and logbooks and stuff, we've moved into spreadsheets, from spreadsheets into software. The basic form of software that we use in facility management is called the Computerized Maintenance Management System, the CMMS. The CMMS is maintenance. It manages maintenance. So what do I need to manage maintenance? I need my asset register. I need to input my maintenance strategy. I need to put in my inventory data. And if I have vendors who work with me, I need to put in their details. I need to put in the details of my staff who do various maintenance tasks, because I need to be able to cut out work orders and assign these work orders. I need to be able to track inventory of certain spares against faults that have been reported in the field that need spares to be fixed, right? So that's basically what a CMMS system does. We move from a CMMS system to a computer-aided facility management system, a CAFM system. What a CAFM system does is take maintenance, which is your CMMS, as one module and incorporate all the other facility management functions. For example, the CMMS will not do visitor time and attendance, whether for staff or visitors, for example. A CMS system will not do space planning and move management. It's not in the remit, it's not maintenance. It will not do operations planning and roster, big plans for security men and cleaning rosters for cleaners and the rest. It won't do that. It probably will not even handle enterprise grade financial information like your budgets for all of your FM, salary and payroll and things. It won't do that. All of these are now additional modules that are worked into a computer-aided facility management system. So a CAFM system is more sophisticated than a CMMS system in the sense that it handles all of the FM functions, including maintenance, which is the core of the CMMS. Beyond the CAFM system, which in itself is still a software that you have to impute data, you have to impute processes, and then you have to put all of those processes or all of those steps for analysis in the software. When you are moving from just facility management to having an enterprise-wide solution that monitors sustainability, that monitors health and safety of the people, that monitors their satisfaction levels, that monitors energy from all meters, that take decisions on how FM is integrated to other departments like finance and procurement and project management in the organization. Then you are moving from CAFM to IWMS. The integrated work management system is like the zenith of management systems. So if you move from spreadsheets to CMMS to CAFM to IWMS, this is the ultimate, because at the IWMS level, your software integrates with technologies in the building. So I'm not thinking about going to read a meter to come and impute the data. The software takes that data and not only fits that data into the operations and maintenance program of my building, it feeds that data into finance, into capital planning. It feeds that data into virtually everything. If somebody's going to do a bidding in the organization, for example, all of the data that bidding will require can be tapped in from the various sensors that are built into the building. So your IWMS is pretty much the top of the range when it comes to your own management systems or software or whatever. You can look at technologies for management. On the building side, you have what we call the, first, to deliver a construction project, architects will do some drawings, engineers will do all kinds of drawings, they will do all specifications. What are they trying to do? They're trying to create it first virtually before it's implemented. Now, all of that information usually will come to us in 2 dimensions. Nowadays, we are beginning to get Revit and other 3-dimensional programs that helps you to visualize even before the items are constructed, okay? Now, when all of these consultants working together are able to work in a single platform that has both 2D and 3D data, that they can all put their inputs, real time seamlessly, we are talking about the building information modeling. It starts with data, it starts with information, but being able to integrate and coordinate all of that information so that they can all work together from design to construction so that everything they do is visible to each other. That's BIM. And I'm going to talk about that because I think I still have a few more slides to discuss that. So why is facility management interested in technology? Why are we talking technology? The problem today in FM is that we have very little data to work with. We don't have enough data. We're not collecting enough data. And when we do collect enough data, in few cases, we don't have systems to actually use that data correctly. I have seen FMs take logs, for example, of your generator. Oh, the temperature is this, the oil level is that, this is this, this is that. You keep putting those data there every day, every day, every day. How many times do you see the FM picking that log, make sense out of that data, and take some very intelligent decisions? Okay, so let's look at what we are trying to achieve as facility managers. We want not technology for the sake of technology, but technology to improve our efficiency and effectiveness, our operational readiness, planning for emergencies, life cycle management of our assets with data that is enough to give us information and insights about where we are coming from, and insight and foresight into where we are going to in terms of the steps we need to be preparing ourselves for. Those are challenges that we need to be looking at. A few basics. We build because of people. All facilities are built globally because of people. We represent the people. We are the people that the real or the built environment is being built for. End users. They live, work, play, and worship, and finally rest in these spaces. Your businesses. Every time there's an investment in real estate, in property, first consideration is we want people to have spaces where they can perform their functions productively in a way that they are also healthy and safe. The owners of assets, we want to ensure that assets are able to be maintained at optimum levels so that the value can be preserved. Most of these objectives don't normally come with most construction projects. I was with a client this morning who's working on a project developing a massive mall, and just the mere mention of having an FM consultant in the project team so that we can all be able to rub minds together and work. It makes sense, immediately to this particular, and this is very rare. Not every developer or owner thinks about having an FM in. And what was the logic? The reality was that each of the other consultants on the project are on the same side as the contractor. In fact, their milestone payments are hinged on the contractor's milestone payments. So if they certify the contractor as okay, they can also turn in their invoice. If they don't certify the contractor as okay, they can turn in an invoice. So in essence, they will need to work closely with the contractor so that there's a win-win between them. What's the need for the owner? What's the need for the future users? Decisions are made that will give convenience to the crop of people who are going to be involved in delivering the project. And that is where operational readiness misses out. The data you need to set up a technology for management is often missed out. I was with another client a couple of weeks ago, not up to 2 weeks actually, and we are building a smart building. We are building smart systems that will be clap, clap, lights go off, and then you use remote control to open windows and so on and so forth. I asked a question. I said, with all of this automation on windows and lights, do you have automation on the sockets and the air conditioning? The answer was no. I said, so if there is a pressing iron connected, or a washing machine connected, or a water heater connected, we can't track and switch things off if someone has mistakenly left them on. No. What is the percentage of your electricity consumed by your lights and your window blinds? How can we confidently say we are creating a smart building that will be energy efficient when 90% of the load is excluded from the efficiency programs that we're putting in place? So we cannot think about any of the things we deliver in isolation of facility management. And so when we think about technology, we want to deploy technology, we're not supposed to think about it in terms of technology itself. We are thinking about it in terms of the people, the facilities, the operations and maintenance, the long-term sustainability and maintainability of that facility. How can we bring in systems that will help us automate, improve this system so that it can become more efficient? Efficiency and effectiveness need to be discussed here. Efficiency is about how we can do things quickly and cheaply. So if you are saving money and you are saving time, you are being efficient. Effectiveness is about being able to provide quality, and quality is alignment with customer expectation. So you can do something very quick, like I asked for pounded yam and egusi soup, and in 20 minutes you got me pounded yam and egusi soup. But the egusi soup was so pepperish, and my mild peptic ulcer would not allow me to eat the egusi soup. You were efficient, but you were not effective because you did not ask me how I want my egusi soup so you can make it as mild and tasty as I want, so that I'll be able to enjoy it. So I can see that you are quick with your delivery. You probably have the food delivered to me at the best price, efficiency. But did you meet my specification? Effectiveness. So if you are trying to put it into technology, do not focus mainly on getting things done quickly and cheaply using technology. You also need to have alignment with the users, the owners. Their specific needs need to be worked into that technology. So what kind of information do you need to be able to deploy FM technologies? You need information from drawings. You need information from bills of quantities. You need information from asset specifications, commissioning documentation. And what do you need those information for? In deploying any of the FM systems, whether it's a CAD system for space planning, with computer-aided drawing or design, computer-aided facility management, CAFM system, either BMS, integrated workplace management system, CMMS for maintenance, enterprise resource planning software like the SAP and Sage and so on and so forth, energy asset management and building automation systems. Whatever the system you are deploying as an FM, you are basically requiring data to incorporate into the software. Why do we talk about technology in FM? We're talking about being able to gather the data, enter the data, use the data, and make decisions, as well as get the data to program certain logic that can even act on our behalf. So whether we are thinking of long-term capital planning or routine operations, we want to ensure that our facilities are maintained and run in an optimal way. So if I take the operations and maintenance systems, all of those are our own management systems, and I take the building technologies, sensors, Internet of Things, keys, controllers, and valves in the buildings, and I marry them together. And I can visualize and create a data that gives me 3D vision, like a digital twin of that integration. What I have is how would I put it? It's a smart building, basically. A building that I can do space planning without having to go to the space. A building that can do energy management without having to go into the space and start pushing buttons and things like that. Those are the kind of buildings that we are trying to achieve as FMs. But it goes, bit by bit. We'll move to those to that level bit by bit, and that's why we're doing technology in today's class. When we looked at our design build commissioning, we said there are certain basic information you need. These basic information are what I have listed here, and I want us to pay attention to them. These information, you cannot run away from them if you are trying to deploy a technology for managing your facility. You need to first create your as-built drawings, asset register, your as-built list of quantities, construction snacks, defect list, remediation schedule. All those need to go in as your deferred maintenance log, of course, as an extension of your facility condition assessment. Construction team and vendor details, equipment guarantees and warranties, manufacturer's operations maintenance manuals, regulatory permits and other legal documentation, testing and commissioning results, contact information of the various OEMs, building systems and equipment specifications, components lists and parts lists, as well as spare parts. All of this needs to be on hand for you to say we are actually trying to deploy technology. But what's our current reality? Inadequate data, poor quality data. If I actually ask you to generate your as-built drawing for your facility today, if you did not have as-built drawings, you will spend days and weeks sketching, measuring, labeling, and dimensioning. And then you will need to now put information on the materials that make up those spaces, your material schedule. It's a lot of work before you now have enough data to create your asset register, and so on and so forth. It is a tiring process that you don't want to go through. And so our prayers is get involved on time, get to see the information you need on time, so you can begin to work with the teams who are building to put information that you need together for you. If they are not going to do it, at least if you are there on time, you can begin to create your templates and start gathering the information as they are burying things into walls and spaces. You have contracts that are delivered by different consultants. Those consultants will come in with different types of reports, different formats. They don't have a uniform format for developing architectural, mechanical, electrical reports. That can become a problem. Most of your equipment lists are captured with scanty information. You have to really go into the asset itself and look at the nameplates on the transformer, on the generator, and actually capture the relevant information that you need for your asset register. Otherwise, you will not have those information. But as a facility manager, you need to be proactive, and this is part of the things we keep talking about. What makes a proactive FM? A proactive FM is someone who is strategic, operates at a tactical level, operates at the operational level. At a strategic level, you are doing asset planning, you are doing capital replacements and improvements, you are creating emergency plans and business continuity plans. At the tactical level, you are creating space management, operations and maintenance plans and budgets and contracts for all of the things that you need to implement. At the operational level, you're actually doing your routine activities to execute what you have planned. Before you start talking technology as a facility manager, lay the groundwork, define what the FM deliverables is. What am I expected to provide or produce as an FM in this facility? Because if I don't know what I should be delivering, I will not be able to estimate how technology is going to help me. So you're not ready yet to start thinking technology. If you are opportune to be involved in the construction or development process, make sure that the documentation that is handed over into operations and maintenance is in the standard format. If not, you have to reverse engineer the process. Okay, and then ensure that data in your operations and maintenance is imputed on an ongoing basis so that you keep having additional information. So what happens when you go into a new project or a new site and you take over that facility and you didn't have data, you didn't have spreadsheets, you didn't have as-built drawings, you didn't have any of those things? It's easy to, cry and complain about how you didn't have all of that. After managing that place for a year, have you reverse engineered the process of generating those drawings and bills of quantities? Have you done your inspections? Have you updated your maintenance program in such a way that there is a clear reporting so that if somebody takes over from you in a year's time, there will be a historical data? Do you have your processes streamlined and arranged so that someone can know exactly what you're doing and what needs to be done if you are not there? That becomes the challenge of technology. You cannot begin to talk about technology if you have not done those basic things. So as facility managers, let's look at some of the things that we need to start focusing on. Not everybody will have this level of maturity. One facility to the next will have different level of maturity for different requirements. And I'm going to look at them, and then you can on your own begin to ask yourself, which one do we have? Which one have we implemented? Which one do we need based on our understanding of our FM deliverables? Asset tagging. We buy assets, we allocate them, we position them, we start using them. The information about that asset, is it in a spreadsheet somewhere? Is it on the asset body on its own? Is it on a bin card somewhere? Or is it in an asset management system? If it's in an asset management system, how do we retrieve information about our assets? I have a table, for example. This table has been here for 3 years. How do I know? How does someone who's been here newly, for example, know that this table has been here for 3 years? If this table's legs were broken at some point last year and a new mahogany piece of wood was used to replace these table legs, how will somebody know what was done and when, for example, on this table? You need to have that information in a retrieval source, which becomes your asset management system. But for anybody to be able to reach into that asset management system, you need to either have an asset number or a coding system, which you can use a quick reference code, QR code, or a barcode, so that you can scan and get into the database that asset is stored in, and then you can update it. You see where we're coming from, going with this. If all you have is a certain spreadsheet that is updated once in a while, can be lost. The information about your assets will become disjointed. So having a system where assets are tagged and coded and scanned into, so you can have access to update and add more information is key to your technology deployment. So start thinking about that. Do we have technology for plumbing leak detection and repairs? Sensors in our plumbing system, or do we wait for the leak to happen and then go and quickly close the valve and start fixing things? Well, for most of our facilities, I think we are not yet at that level where a leak will be so disastrous that the cost of bringing back the facility will be unthinkable. If you are managing a museum, for example, or an archive of important documentation, and you run plumbing pipes around the place, installation of a system like this will help you to prevent, because you have a very high level SLA for dampness, otherwise things will go bad. What about waste collection and management system? There are sensors that can be incorporated into your bins, internal and external bins, refuse bins, so that people making the round to pick up bins to go and empty don't necessarily need to go to every bin. If the sensors can tell, in your phone or in your other device, which ones have passed their level for pickup, it will save time and reduce the employees you're going to put on hand managing those refuse. Energy demand. When you use various assets in your building, at the end of the month, you will know that your bill is so and so amount. For those who are using maximum demand metering, for example, MD, they probably don't know that the peak of your day affects your overall billing. That's why you see those keeper meters. Not many people can read it. The guys come in and they apply some formulas and they tell you what your bill will be, and then they take some logs. You cannot argue with them, because what you should be controlling, you are not controlling. Those things monitor your peak as well as your overall consumption. So if you have a metering system that is circuit level, you'll be able to know exactly what is on at what time, and ask yourself, if this much equipment or assets are on consuming at this time, do I need them all on at that time? Is it possible to program some to work at off-peak, so that I will have a more even curve than a steep curve? For those of us who manage parking lots, I'm sure you must be familiar with parking sensors that helps you to manage how far to search for vacant parking and how you can optimize the use of the parking. So you don't have to open up or create thousands of parking because you've been told one car park to 5 people, for example. You don't need that. You need to study and use sensors to capture data on how your people actually bring cars and how cars stays in the parking lot. And that will give you intelligent information on how much parking you will need now and even in the future. What about video surveillance? I have always advocated the need to do your inspections physically, going about and see things. But then there are some inspections you will actually need drones to be your eyes to see them. Many cases we have video cameras or CCTV set up, and all they do is run round the clock. If you need information from such video feeds, you're going to scan and scan and scan, except you know the particular time you want to go for, you just filter to that particular that time. But if your cameras are set up with intelligent systems for monitoring activity, you not only save disk space, you also save the energy used in monitoring and give you information that is relevant. So if a place is idle and quiet and no movement, there's no need to be rolling the reels. Data-driven decision-making at all levels of management results in effective solutions to problems. You have more visibility into your facility because you have technology installed in your facilities. And then there are all of these basic ones that we have pretty much familiar with, smartphones and tablets. You can do your inspections, you can take pictures. Nowadays, not many people carry cameras around anymore. I'm still one of those old school people that has a small camera. Of course, I've made some progress on that technology-wise. I used to have a DSLR camera carry around all the time from my background as a professional photographer. But even then, when I moved on to a more electronic means of doing things, I still carry a camera. The phone has very sophisticated cameras. Use them. Use them. Capture information, name and tag properly, and use that information to make decisions. Equip appliances with sensors to monitor the condition of the appliance so that you can have predictive maintenance. Remote building monitoring and control combined with occupant recognition system for seamless security management. I know we still use cards swiping. If someone else has that card, the person will have access, isn't it? Yeah. But there are sensors that recognizes people that can be built into our security system for high secure environments. And then Internet of Things is now a covering concept for all FM technologies, especially when it comes to the building technologies. Why? Instead of having sensors wired to a central hub in your building, where the sensor information is, assembled and analyzed, like in the case of the BMS. Now you can have every sensor in their locations actually communicate through to the internet directly, feeding their information into a cloud server where you can have a software installed and you can access that data real time from anywhere. So even if I'm going to create a hub, a computer, a laptop in the office to monitor all of my sensors and all of the data that my technology is bringing in, that information will be processed through the internet and my laptop will not be physically connected to each of the sensors. Same, in fact, in all aspects of your facility management, you can use technology. Think about it. Your landscape system can also be connected so that you get information on how humid the soil is. Imagine that. We put a lot of water out to water lawns, especially in dry seasons, for those who want to keep their lawns green, because that's the service level expected of the customer. And you just water every day. What if the soil and the plants can actually communicate back to you to say we need water or we don't? Same actually watering during rainy season because it's been set up as a sprinkler system to water at so and so time every day. Whether it rained or it didn't rain, the sprinkler works, which is a bit of a waste if you ask me. Sensors can help take care of those. Street lighting, reduce energy consumption and improve safety of citizens. You can have intelligent street lights that come on activity. Even your security lights in your buildings can come on activity, not stay perpetually on throughout the period. Or they could be on dim. When an activity approaches, then they can beam out. And then robots. Apart from drones for inspections, there are some crawl spaces that you may not be able to access as a human based on how the building was constructed. But you can get tiny robots, like inside your ducts, for example. You can have robots go into your ducts, show you what's in there. Now you have robots that actually do some of those operations like cleaning. Instead of going to use mop stick or brushes to clean inside the duct, you can get the robot go in there with a cleaning head or a vacuum head, and then you just remotely control it, go in to do the job. Okay, and then you have analytics softwares, big data software that you can put in all of this data in, and it helps you to predict failure modes and failure patterns in your facility. So you can take decisions as to how to maintain in a way that things will not break down. If you have an SLA that things will not break down or shouldn't break down, you can actually achieve it using data. Somebody told me about light bulbs that cannot go off, that should never ever go off. And I say, like, that kind of SLA is easily achievable. All you need to do is use a certain type of bulb that has been recommended as very good grade, record the time from installation to going out for each bulb over a certain period of time, and then you now know how long it took the average bulb to go out, and you know how long it took for majority of the bulbs to be replaced. Using such data, you can actually program yourself at such a point where you know when exactly to take out all the bulbs, even if they are all working. Because the service level says do not allow a bulb blowout, for example. I cannot really allow a bulb blowout. So if I know the best case scenario is 6 to 7 months, worst case scenario is 1 year for the bulbs I used to use. Before 6 months, while all the bulbs are still okay, based on my data and my reality, I take out all the bulbs, I use them elsewhere, and put new bulbs in. So I can have a continuous stream of SLA compliance without breaking the banks or getting into trouble. And then you have emergency apps, apps that set up alerts in case of emergency, incidents that can be reported, to various kind of authorities, to various individuals. For example, if you have a crisis and you need to activate your emergency preparedness plan, what do? Do you send an email to someone to say there's an emergency, kindly activate the emergency plan? Yes, you can, but there are certain alert mechanisms, certain things that are built into our buildings nowadays. You pull a valve and there's a siren, and then there are some noise to alert people and so on and so forth. But beyond that, you also need to build that building alarm system into some kind of device or software that is carried along with the FM. So you get the alert no matter where you are immediately. I've talked a little about some of these technologies already: smart energy, greener energy generation, lower energy consumption, energy pattern that can be flattened to reduce your peak. That's only possible if you have sensors installed, if you have meters installed at various levels to know. For example, when is your borehole on? Do you know when does it pump? I put an automatic valve. That valve, when the water goes down, the borehole comes up, right? What if that borehole is always coming up during the peak time when all of that load are on? Because water use is heavy during the day, that thing picks up during the day. I won't know that my borehole is combining with my pumping and booster pumps, combining with my laptops and air conditioning, and everything is working at a peak and my energy consumption is very high. I won't know unless I have meter solution that is robust enough to have circuit level metering, so that data can come in from every energy or load consumer. The same thing goes with the grids. Nowadays, I think we have very manual grids. If you have automated grids for a power system, you can actually feed back your own energy consumed that is too much for you. Let's assume you have solar panels, 30 kilowatts worth of feed that generating so much energy during the day, and you don't need that much. It's possible to have a way of feeding that excess generation back into the grid so that the grid can serve that generation. In some countries, you even have metering, a meter that can meter both ways, that can meter what I generate and give to the public supply and what I take from the public supply, creating a balancing mechanism for pricing and reducing my costs at the end of the day. Okay, so water solutions, leakage detection, flood warning are all different technology solutions that we can adopt as facility managers. I'm going to give us a little break here, and then we'll come back and look at CMMS, CFM, and BIM in a little bit of more detail. Thank you. Okay. So let's get back to it and look a little bit more at the CMMS, Computerized Maintenance Management System. It's a software that helps maintenance teams to keep a record of all assets they are responsible for. So that's the first thing. Your asset register is stored and managed inside the CMMS system. Schedule and track maintenance tasks. All your personnel, whether in-house or contractors, their data are stored in the system. And then whenever you have a task, who is responsible for that task? That also helps you to track how the work is done. Each person that gets a task fulfills the task and records details about the task, including cost, time, schedule, into the CMMS. So it maintains a computer database of information on maintenance operations, end to end in your facility. If you are thinking about FM software for the first time, I think this is the basic level to start from. Let's get a software for managing our maintenance. Okay, that's where to start from. Some organizations may not buy it because of maintenance. They will say, oh, we want to buy it because of our asset management. We want to have an updated database of all our assets. Super. So that's just for maintenance or for asset management. It's basically two birds being killed with one stone. To implement, you need to get top management commitment. Buy-in is very key. Many FMs propose software as a way to reduce their workload. I can assure you that's not a strategy to use. If you're already doing the job right now and nobody's complaining, and you now propose software to make your life easier, per se, then of course, you won't get management buy-in. You need to come up with efficiencies, where that efficiency was, that speed and cost implications, and then effectiveness, alignment with strategic higher level goals or objective of the organization. There must be something in the mind of management that you can tie your technology adoption into. So once there's a buy-in, okay, we can use the software. Define requirements. What are my goals for deploying the software? What are my expectations? Some of those things are promise management as the good things that are going to happen on the side of efficiency and effectiveness from this software. I need to now define them, break them down, amplify them, using various stakeholders' point of view to come up with what my expectations are. And then what kind of hardware we will need. For example, are we going to need a device installed, or do we want to work it in our phones or in our tablets and in our laptops? All your assets must already be documented. In essence, no asset register, forget about technology, including everything relating to the assets, capacity, size, dimensions, date of this week. We've done the asset management class, so you see all of those things that must be in your asset register. Then you need to have your processes for getting things done. How do we handle preventive maintenance? How do we handle reactive maintenance? How do we handle various tasks? You need to itemize activity by activity, and for each activity, these are the steps that we take. Because the processes will need to be configured into the software. If an individual in your organization who has a link to raise a complaint, for example, or a request, he clicks on the link, you put in all the asset register data, you put in all the space hierarchy data. which means the person can actually scroll down, see his own space, and then see a list of all the assets in his or her space. Pick on the one that's giving him problem. It's a wall, it's a floor, it's a fan, it's an air conditioning, whatever. Pick on it. If that asset has subcomponents, be able to select which subcomponents and then describe the kind of faults. You can even categorize your faults such that the description will only be a way of describing something that has been categorized. So just pick one category of faults and then add a sentence or two to describe it. Now, if that person puts in that information and submits it into the system, where does it go? Should it go straight to the MD's inbox? Should it pop up as a reminder on the FM? Should it head to procurement? Should it go to finance? Should it go to that person's supervisor? And so on and so forth. You need to configure the process flow for that activity, because that's the only way the software will work. Otherwise, nothing will happen. So you put in that information, you save it in, it now becomes an automation. Somebody puts in the request, it goes to the FM, reviews it, and then assigns it to a technician. The technician picks it up, goes and does some scoping on site, updates the scope, requirements for funds, requirements for all kinds of materials, and he submits it. As soon as he submits it, if those materials are inventoried materials in our warehouse, that material that is an inventory material in our warehouse, the technician is able to see the balance of that material in the warehouse and automatically book for that one. The rest that are not available in the warehouse are booked for purchase. The ones for the warehouse goes to the warehouse so that there will be a warehouse issue notice and then a delivery note that will be signed. And then the ones that will be for purchase will go to procurement. People will pick this up and act on them. And once they are done, they will submit it back into the system. It will get back to the FM, who will say, yes, technician, your work is ready now, you can go and execute. If you don't have those processes predetermined on paper, so that the guys who are coding or configuring your software can translate that into process code inside the software, what do you have? So I hear of FMs buying a CMS system off the air, Airtable or any kind of automation you want to use. But the software in itself cannot do anything for you. So your processes and procedures must be documented before you can implement the software. And then, of course, when buying the software, let it be one that suits your needs. Let the software be made for you, not you made for the software. I've seen some Nigerians using softwares that you cannot change dollar to naira, for example. You cannot put our kind of addresses. You cannot put certain things about our own configuration. It doesn't just make sense. Why do you struggle with that? For some, the software comes with a default process layout. That process is not how we work. Because we are so lazy to document how we work and set up our own process in the system, we buy the software, put our asset register, and put all our data inside there, and then the system begins to determine how we should work. That is not proper. Okay? Except you don't know how to work. What you are doing right now is so upside down that you don't trust it and you don't believe you should be doing that. And you now need the software to teach you how to work. Then you need the software provider to give you a default process or to get a software integrator to help you implement your processes or certain standard industry processes into your software. Import data you have from existing systems and spreadsheets. If you have an existing system like a procurement software where there are certain data of your assets, finance software where there's asset data as well, you can actually use download templates from those software and import them into your new one. You add your users, There are users entered into a software and given different permission rights. Those who can just make a request, those who can act on things, those who can recommend, those who can close out a work order, and so on and so forth. So you've added your assets, you schedule your maintenance. The point of scheduling, you've gone beyond putting the processes and the frequencies for most activities in. You now want to start it. So things that should happen every Tuesday, for example, from next Tuesday, the first one will happen. I could keep listing them on and on like that till you know, as long as that program is in place. Then you go live. At the point of going live, you are now sure all your data has been imputed into the system. The system is now ready to serve you, but you cannot leave it like that. You have to keep tweaking the processes, ensuring people are using it, having process improvements, review, renew, refine, and customize on an ongoing basis. So it serves your need better and better. And if for any reason you are changing processes, you are expanding your team and to add more process or more activities into the system, then you should. Don't get a system that limits you from growing or contracting as you may wish. So the next level is the CAFM that we talked about, the computer aided facility management system. It manages everything, not just maintenance. So examples of space management, for example, how to report on all of your operations, how to plan all your operations, basically everything that you do in facilities. You can program them into a computer-aided facility management. So you can just think about all of your functionalities, all of the things you deliver as an FM, and know that a CAFM system can actually handle them. Things like building services, costs, of course, maintenance is there, furniture and space, individuals, people, customer service, response times and things like that can also be tracked inside the system. It enables strategic planning, space management, space forecasting, continuous improvements, to improve your FM efficiencies. Because right now, with a CAFM system, you are able to have visibility into your workers. For example, cleaners. Cleaners don't normally go into maintenance CMMS system, but in the CAFM system, yes. You can also track vendors and their various activities. You can track various customer groups and what they have been able to, what their complaints and concerns are, and how you have been able to resolve them. And virtually every report can be configured inside the computer-aided facility management system. Reports on customer satisfaction, reports on water use, energy use, reports on space utilization, reports on environmental metrics, sustainability metrics. So many things can be done inside. So it's your complete software for managing your facilities. Okay, beyond maintenance. So that's a clear line. So if you have a question that says, what's the difference between CAFM and CMMS? You basically say CMMS is for maintenance and CAFM is for maintenance and all other FM operations and planning and execution. Okay, so the same set of considerations for implementing a CMMS system will also apply in the CAFM system, but there's an expectation that you have matured a bit. What that means is that you are now familiar with the use of software. Okay, so because of that level of that maturity, you can actually have few other considerations, including system specifications. You have an organization that has a certain type of server, or you're trying to get a CAFM system in. You want to be sure that it will integrate. You also want to ensure that you invest in implementation. Many people buy the software and think that's the budget. No, the budget really is 20 or 30% software and 70 or 80% implementation. So getting the consultant in to work with you to actually deliver the integration of the system to work for you is a big deal, because sometimes you think, oh, well, we have all our data. I got a call from the company today. We're going to do facility management outsourcing, will you be interested? I said, yes, we'll be interested. But you will need to first do this and that information that we need. Oh, we have all of those information. We have an FM department. And that's what I always hear, right? But by the time you get in there, you now realize that the FM department that they thought they had, they never trained. Those guys have been moved from other department to that department over the years, and they've just been doing things the way they feel like. And management don't know how to check them or give them information on what to do. So all of those things I am quoting professionally as things that needs to be done. They will think they have it in-house from procurement or finance point of standpoint, and they don't necessarily have them. Okay, so invest in professional implementation so that they will bring in best practices and be able to deploy for you properly. Whether CMMS or CAFM, there are a few challenges with deploying them. Management will often not see this as value adding. You want to spend 2 million, 5 million. What is the tangible benefits? What are you giving us in return for this 2 million, 5 million investment? So that visibility is not always there. So, and then because it's tied to maintenance, it's almost like maintenance is already costing us a lot. You're not asking us to come and buy technology to make maintenance even more expensive. And then sometimes it's resources. We don't have the right people, trained people to manage our software. Some people are pretty good, especially this young generation. Is this Z now? People that are, very quick to pick up new electronic or technology skills. Yeah. So, but you need to have the right people who can operate, who can run it, who can champion it. And then, but political priorities, always, every time you have needs to make an investment in an organization, there will always be that do I like him, do I like it situation where whoever is going to make a decision, we need to decide whether he likes the concept or the idea of making that investment, as well as whether he likes the person who is going to handle it. Because if that's not, if that balance doesn't happen, the investment will never happen. And then, of course, on funded mandates, management says, go and do this. We need to get this done. We need to meet so and so objective, but there's no budget to back it up. I think one of the biggest challenges is not even money, it's data. It's data. We as FMs, not having structured data that is ready for technology. And then, of course, operational stovepipes, where you have silos and people working in different departments or units, not blending in a matrix format. That can become a big problem. So if I'm the one in charge of, let's say, sub-services, all of the cleaning and grounds and environmental works in the estate, and then someone else is in charge of the engineering works, who is in charge of maintenance, generators, and the rest, who should push for the software? And when the software is going to be brought in, will it be for just that unit or department or for everybody? That can be a problem. Challenge for FM is to overcome these obstacles by utilizing the resources available and convincing leadership that efficiencies and cost savings can be achieved with investments in technology, such as a well-planned CAFM system. I talked about BIM when I was doing an overview of all of these management technologies. BIM is building information modeling. That's the definition of BIM. Intelligent 3D model-based process that equips building professionals with the insights and tools to efficiently plan, design, construct, and manage buildings and infrastructure. Generation and management of digital representations of physical and functional characteristics of places. Files can be exchanged or networked to support decision-making about the place. Digital presentation of physical and functional characteristics of the facility, and a shared knowledge resource for information about the facility, forming a reliable basis for decision during its life cycle. If experts who worked on a building project from design to construction actually have such a rich concentrated data handed over to the FM. The FM does not need any of those long lists we are providing. All of those commissioning data, warranty information, spare parts, they will all be there because every detail would have been entered into the BIM system by all the various engineers who work on the system. So it's basically I won't call it a software, it's a data system, data management system. That's why it's called building information modeling. It's a data management system that actually has data in spreadsheets converted into 3D images. So I can see a building, walk into the building, see that the floor is made up of marble tiles, click on it, and a small spreadsheet will crop up telling me the type of marble tiles, the year it was made, when it was installed, how to maintain it. Any relevant information I need about that marble tile will be available because it's now embedded into the model. It brings together all of the information about every component of the building in one place. It's used to illustrate the entire building life cycle. And information is added to the model on an ongoing basis. So if an FM does a maintenance or a repair or a replacement, he updates that information into that same database. So that's why I call BIM more of a database management system. It's an information management system. It is data that is backed up with visualization. So I can see the building, but it's not just a picture that I'm seeing that is there. Every detail about every socket I point my cursor to, every wall I point my cursor to is presented to me because those details are all embedded into the system. Scheduling, estimation, and risk analysis, of course, during construction, it helps to reduce scheduling issues. It also reduces friction between various functional groups during construction. They collaborate better. And when you get to FM, I will not be forcing a template into their hands to put information for me. There's a standard template in a BIM management system that it has a way of capturing all of the information, and I can download my asset register using an international standard. So I don't even need to create a separate spreadsheet and say, I want this on this column, I want that on that column. No, I can filter for what I want and it will download my asset register for me the way I want it. So productivity, of course, you can actually model how different things will work in the building. If I'm going to use a certain type of glass, for example, how would that affect energy? How would it affect sun ray in the building? How would it affect lights? I can model those by putting them in the building first and observing it and take some numbers to look at what the impact is and switching to compare it to another one. Productivity and cost reduction, reworks. I don't necessarily need to make a mistake because I can make the mistake inside the model. Trying out something, if it's not going to work, I try it again until it works before I go ahead and build it. Can you imagine how that will reduce my cost of construction? Provides related documents, gives complete project snapshots, improves coordination and enhances customer satisfaction. Because of course, at this point, there's so much visibility. Anybody you are sharing that information with, the person is going to see a lot more information than questions that they may have, because all their questions would have been answered because the data is, it's a very data-rich system. All right, still talking about some of the technologies I've introduced before, the building management system, a control system that can be used to monitor and manage the mechanical, electrical, and electromechanical services in the facility. The standalone application is built, the sensors are wired in, and then you have a hub, and then you have a computer that sees all of those sensors, and you can monitor them, both sensors and video feeds. Controlling is what it does. So if I get the data from those sensors, I can act by switching things off and on, opening up and closing using the BMS system. Okay, so controlling and monitoring. So it primarily monitors and then I can as well control. Internal comfort conditions, BMS helps me to know whether there's too much oxygen, whether it's too hot, whether, I mean, CO2 rather, whether it's too hot, whether it's too cold, and so on and so forth. I can improve satisfaction of my customers by monitoring the situation around them, because I have sensors all around them. And when I have, when I'm going to have issues with my facility, I can know upfront. I can know that this is going to become a problem because data is coming in. Okay, and then when facilities or assets, equipment are consuming energy, I'm getting a log of how the energy is being consumed. Make intelligent decision and act using a BMS. So basically, there are companies that deploy BMS, but for us as facility managers, our job is to learn how to use the BMS as a tool for our management of our facilities. And BMS are not really cheap. I think they are going to go out of use soon, because you see all of these components and hardware that comes with BMS, they're very expensive. If you have a 10th floor high-rise or a massive mall today in Nigeria, you probably will be looking for up to 150 to 200 million to have a functional BMS system installed that will monitor and control everything. So it's really, really exorbitant. So in place of that, now we are having Internet of Things sensors that are coordinated using software in the cloud that are much cheaper, that can gather all of this information, that can also feed information back to controllers that you can get from the market. So in a way, instead of having a custom built off-the-shelf BMS system, you can create it using more advanced sensors that are very cheap. Some sensors are so cheap, less than $10, $5 sensors that can send information to the cloud and give you controls that you probably will not even get with a BMS. Now, but a BAS is a different ball game altogether. While a BMS will not give you automatic control, we said the BMS gives you control, which means once I see the data, I see the condition, I can act, you know. But in the BAS system, the building automation system, the system has been pre-configured with my thinking. So the system will act. A BMS system can tell me there's nobody in the hall so that I can switch off lights and switch off cooling. But the BAS system, once it knows that there's nobody in the hall, on its own, we switch off cooling and lights. So it's an advancement on the BMS system. Logic is now written into the system to be able to take action on its own. That's what the BAS does. Monitor and control the mechanical electrical system in the building. It is centralized, interlinked networks of hardware and software which monitor and control the building environment. If a building has a BAS system, we call that building an intelligent building or a smart building, because the building now thinks. A BMS building, a building with a BMS is not an intelligent building, it's not a smart building. Well, we can say smart to an extent because it gives you information that you can use to act. You are the one doing the smartness. But in the BAS equipped building, the building itself is doing the smartness because it takes decisions based on instructions pre-coded into it. For example, you can control your air conditioning temperature and align it with outside temperature. So if temperature outside is low or too high, you can balance it. You can also read temperature of people's body inside the building and do automatic adjustments for lights, for water flow, for cooling flow, for fuel and other consumption, other consumables. Everything can be managed using a BAS. Energy savings is one of the biggest benefits of BAS. You remove human error. BAS can save you up to 30% of energy costs in your HVAC and lighting system. And as such, reduce the environmental impact, helps to improve security as well, because of course, there are sensors everywhere. They know when somebody is where, you know. helps to improve building maintenance. You know the area that has been used to receive attention, the area that should be left alone because nobody has used them. Operator convenience also helps to make you able to plan your work. Gives you real-time status updates, so it's able to tell you what's happening right now in any aspect of your facility, and you can have continuous access to your assets. So lighting, HVAC can operate on a schedule. Various components in the facilities can work together with greater efficiency. It optimizes the flow of incoming and outside air, for example, freshness, temperature, comfort inside the building. Tell your HVAC units, tell when your HVAC unit is running in both heating and cooling, helping to reduce utility costs. Can know when, for, you know, there are some HVAC units, you know, abroad, not here, that has heating and cooling aspects, and some people can be on one room using heating and the next person is using cooling, just burning your energy at both ends. Can know when an emergency such as fire breaks, you know, are happening, to be able to turn on systems that can help to control fire and detect problems in the building, help you to be able to see where you're having a problem and take care of them. Yes, and the question whether a BAS system can be integrated into an old building, yes, that answer is 100% yes, because now the components of this automation, there are two components, right? You have the sensors that are connected to the equipment, assets, you know, like lights, HVAC or whatever, bringing data into the system. And then you have a software in the system that is built with the kind of logic to interpret those data. And when it interprets those data, it sends information to another type of sensor that is connected to a controller. For example, if I have a changeover switch or a fire hydrant system, for example, when the information comes from the sensor that has sensed the smoke or the heat, it's interpreted within split seconds. The information now goes to another sensor that is connected to the control valve or the switch that controls the fire hydrant system, and that sensor tells the switch to switch on that hydrant system. So there will be, it's not a two-way connection. A sensor that brings in information, a sensor that receives the decision of the BAS system and tells the controller, which is often a physical controller, to actually act and save the day. So basically, if anybody wants to deploy a BAS system, what we basically do is study the facility, look for the appropriate, proper kinds of sensors, both types of sensors, and then get a software. Most of this software are already produced, they're already built. It's just to get the various sensors, you know, and their IPs, you know, configured into the software in a cloud setting, and all your data starts coming in and your action. So you now configure what needs to happen. For example, you want all lights inside to go off at 8 p.m., for example, irrespective of whether somebody is in the building or not. I'm sure you don't want that, right? So because you may have somebody inside there and the person will be trapped, you know, in the building. So you want the sensors that identify whether there are people in all the spaces to be able to communicate back to the system and say, why switching off lights, leave so and so spaces because there is somebody in so and so spaces. Okay, so basically, those are the kind of things we're talking about. They are sensors. Sensors now are not, if they don't even need to be intrusive, unlike before where you have to have a sensor right inside the transformer, right inside the generator. Now sensors can be hung around cables, for example. Sensors can be embedded into the dashboard or the display screen of your devices, and they'll just be tapping the information from there and, you know, sending it out. For many of the devices we have these days, they have a USB point, they have a Modbus point, they have certain data communication interfaces, built in with them that you can just go and plug in one plug your sensor into one of those to get information and send to you for work. Cisco reports there will be 50 billion connected devices by 2020. So how many will it be by 2021? How many will it be by 2022? What it simply means is that sensor technology will go beyond industrial. It's going to go into our daily life. You are wearing a Fitbit, Google or Apple Watch, for example, and that device is taking your blood pressure, your blood sugar, cholesterol level information. It's taking your heartbeat rate. It's taking all kinds of information. And what is it doing with those information? It's probably sending those information to a certain doctor, a certain health tracking app, right? Which tells you that you will soon break down if you continue eating so and so stuff because your lipid level is very high or something is happening to you, okay? And then very soon, I mean, in advanced countries, you already see this happening where that information can be fed back to your refrigerator to say when a certain product finishes in your fridge, you don't need to restock it because your health level will not carry it. And your refrigerator is connected to your logistics company that does your grocery supplies, that tells the company, oh, your milk is going down, they should deliver milk to you. So you can actually automate your entire life now using sensors. I give you the example of waste bin, for example. A cleaner can have a 10 floors building and pick out all the trash in the 10 floors in less than 30 minutes because it doesn't have to go to every trash can. It only goes to the one, maybe they just had a meeting, doing some brainstorming section, they folded paper and the trash can is full. The sensor hits him. He goes there, picks that one. And for that period, he knows that it's only 1 or 2 trash cans that were full. Next 1 hour around, he knows exactly where to go to. The building will maintain at pristine levels without having those people milling around the whole corridors or having people holding mop sticks and standing outside your bathroom to mop wet floor, because if there's wetness, something will trigger a notification. So that's what's going. There'll be a lot of data, but the data is unstructured, and I think that's the biggest challenge right now. We have a lot of data in FM, but the data is unstructured. The data is not. We're not able to use the data, and we need to find a way to organize our data into something we can use. A word on cyber threats. You know, we are talking so much about data. Information is being gathered about us, by us, with our consent or without our consent everywhere. We are signing into all kinds of stuff. Your digital imprint, when you log into anything, that system records that you are the one that logged in. If you give your password to someone else and the person logs in, the system records that you are the one that logged in. And the system records what happens with that login as you that did it. So when we do all of this technology deployments and have all this data, you know, we provide access to data at different levels for different people. You don't provide a cleaner, full financial data access of your facility expenses, even though the cleaner has access to the software where all that data is involved, right? So data breaches become very easy if someone gets access to maybe an access code or a password to a higher level access, can just download information. So let's be mindful about how we use our security. Many people have passwords that can be so easily guessed. For example, I've actually learned to forget password. Every time I log into some sites now, I don't even bother to try to remember. I just click on forget password so that I reset it immediately and use it and forget it again. You know, so some of those things can become very dangerous and very risky over time. because more of our data go online, go into these systems. We actually need to be conscious about how this data is assessed. And then sometimes I wonder this whole thing about passwords, you know, there are biometrics. Systems can scan the eyes, fingerprints, and so on and so forth. So I think technology should also be moving in that direction, where biometrics will help us to reduce the likelihood of data being, you know, getting into the wrong hands. Okay, so that's our lesson. Basically, IT must serve the needs of the business, not the other way around. We talked about this. Your processes must be in place before you can say you are developing, adopting the technology. Don't rush into technology adoption. Let's look at what are some of the things you must have in mind before you start a committed team, people that are actually passionate about doing things better, people that want to learn and do things take on more challenges. They should be in the team, and then you get people to brainstorm. Don't on your own do an evaluation. You do evaluation. You get other members of your team to also do an evaluation, and try to get consultants. You know, if people like us who are consultants in the FM industry don't get jobs, to be a lose-lose situation for everybody, because at the end of the day, you're trying to make progress and you're not willing to pay for the consultant's work. And then you go ahead and deploy something that turns back to be a value loss. I can tell you there are some huge value losses in our industry. Some companies have deployed software, 500 million, 1 billion in investment. And after 3 to 4 years, they packed it up. No return on investment because it wasn't properly implemented, okay? And then don't buy software that will only meet today's requirements. Plan for the future today. Then when you're buying software, read the small prints. If I put my data inside your software, does my data now belong to you or is still mine? Read the small prints, okay? And then planning for deployment, work from a go live date, work backwards. What it means is that you decide that I'm going to have my software in place by so and so time. Once you have that, make that decision. Then you start your plan in such a way that at that time you must have your software in place. And then also learn to celebrate small wins. If people are able to put together certain data, you know, appreciate it, you know, and so let tasks come in chunks. Let it not be overwhelming. Let's take phase 1. We'll plan our job in such a way that it will be phase 1, phase 2, phase 3, phase 4. So we'll be going little by little. Phase 1, let's get our asset register. Phase 2, let's get our processes in place. Phase 3, let's use a small spreadsheet to automate it. Stage 4, we'll get a trial, a demo software that is free online, and then we'll start using that to learn how the software works. And then stage 5, we'll start investigating which software will meet our needs. Stage 6, we'll deploy, we'll employ a consultant, and so on and so forth. We'll take it step by step. That way it will become easy to fail. So if you have to fail and start again, you can actually recover easily than if you approach it in a very big way and then you crash land. And then even when people are saying, oh, this thing is working well, we are getting it right, check in intermittently. There must be a coaching or hand-holding process where people can actually be reviewed how they are actually using the software to ensure that they're actually making progress as proposed. Finally, some deadly sins of technology deployment: lack of realistic expectations. Don't expect that once you have this software, it's a silver bullet. All my problems are solved. Specific items not itemized. You just go for software because it's time to get the software. You didn't write down what you want to achieve as specific outcomes, because both the integrator, the software provider, your team, you know, everybody needs to understand what's the specific outcome for you. And a lack of commitment. Many people are just getting into software, they're not really committed to it. So management say, okay, well, let's fund it, but they really don't see it as something that will bring the desired result, and they're not putting any effort to make it work. Lack of planning, lack of quality, lack of communication, and lack of authority. Sometimes the FM is trying to go on its own and doesn't have the empowerment from top management to take decisions or act in ways that brings the kind of success it's looking for. So this is just an economic example, something that you can look at in terms of an example of software justification. You know, you want to deploy, and you are thinking of how to get management to consider. So look at the initial cost. You look at the ongoing monitoring. You know, web-based, for example, cloud renewal for software consultants, and then you compare all of that to the energy cost saving. Yeah, so if your software is going to bring a tangible result like energy cost saving, that can become the benchmark which you are going to use to prove to management that this is a good buy. Okay, so that's our class for today. I'm going to give a 5-minute break, and then we'll come back.